Hi dear students, we are going to study about standard form in this lesson, and here how to write the standard form. Basically there's a definition here and these are the examples. So for a number to be in standard form, it must take for form a times 10 to the power of n. N can be positive for negative integer, but a must be between 1 and 10. 1 is included also. So 100 can be written as 1 times 10 square. 1000 can be written 1 times 10 cube. We know that 100 is equal to 10 square also, but this is not the standard form, not in standard form. What is the standard form? If it is written 100 written 1 times, or here it is not necessarily the cross, here this one 1 times 10 square. If it is written in this form, then this is the standard form can be. So for the next one, it should be equal to 40,000, which means 4 times 1, 2, 3, 4, 10 to the power of 4. This is 3 times 1, 2, 3, 10 to the power of 3. It has to be. Here, write down the 72,000 in standard form. Firstly, you are going to think that maybe 72 times 1000 or 72 times 10 to the power of 3. You may think, but this is not standard form. This is not standard form because it should be, the number should be between 1 and 10. 72 is bigger than 10, which means that we are going to do like this. 7.2 times 10 to the power of 4 is the standard form. This is ordinary number. We are going to write in ordinary number 1 number form, which means that after 4 I'm going to add 40. Here I'm going to multiply these two, then I'm going to write in standard form. 6 times 4, 24. There are 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. But this cannot be 24 times 10 to the power of 5. This is not in standard form. But if you write like 2.4 to the power times, 10 to the power of 6 is in standard form. Okay, let's continue with the operations. Here the first operation is multiplication. You remember from the multiplication between the power expressions, when we have a to the power of n times a to the power of m, should be a to the power of n times m plus m. So we are going to do like this here. When we are multiplying these two, we are going to combine them, like 2.4 times 5 times 10 to the power of 4 times 10 to the power of 7 can be written. I especially use the cross because of I didn't want to change to point to confuse you. So 2.4 times 5 times 10 to the power of 4 times 10 to the power of 7 is equal to, times 10 to the power of 4 times 10 to the power of 7 is equal to 10 to the power of 11. It's going to be, now let's multiply these two. 2.4 times 5, it's going to be equal to, if we multiply 24 by 5, it's going to be equal to 96 plus 120. 120 times 10 to the power of 11. But this is not standard form because 120 is bigger than 10 now. So I'm going to make the number smaller than 2 decimal unit to left. So 2 point I'm going to add to this side, which is equal to 1.2 times 10 to the power of 13 is the standard form. But here, let me do this one clearly. Times 10 to the power of 13 is in the standard form of this number. Here, as I did in the first part, I'm going to collect firstly the numbers together, then the powers of 10 together, but I have to write with fraction to understand better. Times 10 to the power of 7 divided by 1.6 times 10 to the power of 3. Here I can separate 6.4 divided by 1.6, then times 10 to the power of 7 divided by 10 to the power of 3. I can get this one here. I can get this one from a to the power of 7, actually a to the power of m divided by a to the power of n, which is equal to a to the power of m minus n. It has to be. So with respect to that one, this part, it's going to be 10 to the power of 7 minus 3, but this one, what it should be? 6.4, 64. If we say 64 divided by 16, which is equal to 4, so 6.4 divided by 1.6, it's going to be equal to 4 again. So 4 times 10 to the power of 10 to the power of 7 minus 3, which is equal to 4. It has to be, and this is the answer of the question. It has to be. Here, for adding and subtracting, we have to be careful about this here. What is written here, we have to be careful, because when you are adding and subtracting, the powers of the 10 should be same. Otherwise, you cannot add them. If you want to add them, you have to make the powers same in some way. So generally, I'm going to prefer the make the powers. I'm going to make bigger powers. I'm going to use bigger powers. Then I'm going to add the numbers, which means that if this is 3.8 times 10 to the power of 6, then this is going to be 10 to the power of 4. I need to make this one 10 to the power of 6. When I make this one 10 to the power of 6, this decimal moves to left 2 units, which means that plus 0.087 it has to be. So times 10 to the power of 6, it's going to be times 10 to the power of 6. Now, since the 10 to the power of 6 are same, I can add the numbers like this. 3.8 times, I'm going to correct this part, 3.8 plus 0.087 times 10 to the power of 6, it has to be. This is like isolating the common factor. These two factors are common, so we got outside, and we are adding now this 2, which is equal to 3.8 times plus 0.087. It has to be 3.887 times 10 to the power of 6. It has to be. If you do the other operation, let's say if you make this one to power 4 and to move this one 2 units, right, then you will get a number which is bigger than 10, and then you need to reverse it back. That's why it's always better to choose bigger power here. So when you're subtracting, again, you're going to do the same thing. I'm going to increase this one 2 units up, which means that I'm going to move the decimal point 2 units left, which means 6.5 times 10 to the power of 7 minus 0.092, 2 units left. So times 10 to the power of 7, it has to be. Again, I'm repeating, when I increase the power 10 here, I'm going to move the decimal point 2 units left, and I'm going to get the power 7. Now the powers are same. I can collect the common powers together, which is times 10 to the power of 7 and 6.5 minus 0.092, it has to be. Of course, 6.5 minus 0.092, I can add here 6.500. Actually, 5,000 if I do, that's better, because 0.092 here, it's going to be 92. So there's no need to the third decimal need. Minus, it has to be here. And from like I'm subtracting, normal subtraction I'm going to do. From 0 we cannot, but if I get here from near 1, then 10 will be 10 minus 2. It's equal to 8. It should be, this is 9. This is going to be 0. Here, this is going to be 4, because I cannot take Yeah, and this is going to be 4 now. 4 minus 0, it's equal to 4. Then here, we didn't get from here. That's going to be equal to 6 again. And 6.408, it should be 6.408, 6 point, like it seems multiplication. That's why I'm going to write here 6.408 times 10 to the power of 7 is the answer of the question. Okay, now we are going to continue with the negative indices and I'm going to solve some exercises. But before then that one, I want to mention that here when it is like when we are writing 100, it's equal to 1 times 10 to the power of 2. 10 is equal to 10 to the power of 1. 1 is equal to 10 to the power of 0, it should be. Then when you go to decimal, so 0.11 to the power of negative 1, negative 2, negative 3, it continues like this. Or when I move the here, let's say 2 times 10 to the power of 3 when I say, if I move the decimal point to the left side, like if I do like this, it becomes 0.2 times 10 to the power of 4, which means that I'm increasing, or 0.02 times, if I say, this time 10 to the power of 5 it's going to be. So when I'm moving to the right side, I'm increasing the power. When I'm moving to left side, I'm decreasing the power, which means that if I return this one to this side, let's say from this one to this side, let's say 20 times 10 to the power of 2 it has to be, which means that I move the decimal point to the other side, which becomes 20, and I decrease the power. So 200 times 10 to the power of 1. But these are not in standard form. Which one is standard form? 2 times 10 to the power of 3 is the standard form. 0.2 also it is not in standard form. We need to understand that one. Also, we need to understand for the negative indices, the rule is same. A should be between 1 and 10. So what it should be here, 32, we are going to bring in form like this, 1, 2, 3 unit to the left, which means that 3.2 times 10 to the power of minus 3 it has to be. If I write this one, as ordinary number, since there is minus 4, I need to move this 1.8. I'm going to write here 1.8. 4 units right. 1, 2, 3, 4 units right. I'm going to put the decimal point here. Here, every place, I'm going to place the zeros. Then I'm going to write this number here like 0.00018. 0.00018 is the ordinary number form it has to be.